Most data engineering tutorials show you the happy path. The file is clean, the schema is perfect, the pipeline runs, the dashboard looks beautiful, but production data does not behave like that. Production data is late, duplicated, missing columns, wrong formats, negative revenue, broken files, and stale dashboards. So today, I'm going to do the opposite of a normal tutorial. I'm going to take a working data pipeline and break it on purpose in 10 different ways. The question is, can our data quality checks catch the problems before bad data entering into dashboards? And by the end of this video, you will have a checklist for making your own data pipelines more production ready. Hello everyone, welcome to Big Data Factory. I am Pranit and I have over 4 plus years of experience working as a data engineer. If this is your first time visiting this channel, don't forget to subscribe for more content on big data and real world insights. Here is the pipeline we are starting with. It is simple on purpose. We have raw orders data. The pipeline cleans the orders, creates a revenue table, and then powers a dashboard. The data has columns like order ID, customer ID, order date, country, product ID, quantity, price, and payment status. The final dashboard shows daily revenue, revenue by country, and total number of orders. Right now, everything works. The pipeline runs, the numbers look correct, the dashboard is clean. But that does not prove the pipeline is production ready. It only proves it works when the data is friendly. So let's make the data unfriendly. Here are the rules. I will break the pipeline 10 different ways. After each break, we will see 3 things. What went wrong, whether the pipeline catches it, and how should we fix it. I will keep a scorecard. If the pipeline catches the issue before it gets a pass. If the bad data reaches the dashboard, it fails. Let's start with one of the most common problems in data pipelines, duplicate rows. Break number 1, duplicate orders. I'm going to take some order IDs and insert them again. Now let's run the pipeline. At first, the job succeeds. This is already a warning sign. Now let's check the dashboard. Revenue increased, but not because the business made more money. It increased because the sum orders were counted twice. This is dangerous because it looks like good news. The dashboard does not show an error. It shows fake growth. The fix is to add a uniqueness check on order ID. We should also design the pipeline so reruns do not append duplicate data. So for duplicate rows, the production lesson is always define the business key and always test for duplicates. Score. If your check catches it, pass. If not, fail. Break number 2, null order IDs. An order without an order ID is not just a small issue. It breaks deduplication, it breaks joins, it breaks traceability, and it makes debugging painful. So I will add a few records where order ID is null. Now when the pipeline runs, what should happen? The bad records should not go into the final clean table. They should either fail the pipeline or go into a quarantine table for review. This is a good pattern. Do not always throw away the bad data. Sometimes you need to store bad records separately so the business or source team can fix them. The fix, add a not null check for critical columns. Order ID, customer ID, order date, and payment status are good examples. Production lesson, not all columns are equally important. Critical identifiers should have strict checks. Break number 3, negative revenue. I'm going to add orders where quantity is negative or price is negative. Now sometimes negatives can be valid. For example, refunds can be negative. But if this is in an orders table, negative quantity or negative price may be invalid. This is where business context matters. A technical check is alone not enough. You need to know what the data means. If the business says order quantity must be greater than 0, then the pipeline should enforce that. So the fix is add expected range checks. Quantity must be greater than 0. Price must be greater than or equal to 0. Payment status must be one of the allowed values. Production lesson, data quality is not just technical. It is business logic converted into tests. Notice what is happening here. The pipeline is not failing because the code is broken. The pipeline is failing because the data is lying. And that is what makes data engineering different from normal software engineering. In software engineering, a bug often means the code crashed. In data engineering, a bug can mean the code succeeded and the numbers are wrong. That is much scarier. Now let's break something even more realistic, late arriving data. Break number 4, late arriving data. Let's say yesterday's orders file arrived today. If our pipeline only processes today's file, yesterday's revenue will remain wrong. This happens all the time. Files arrive late, events arrive late, APIs have delays, source systems backfill data. So the question is, can our pipeline correct the past? A weak pipeline only processes the current data. A stronger pipeline can reprocess a time window. For example, every run can reprocess the last 3 days, or we can support manual backfills for a selected date range. The fix: use event date, not only processing date. Partition data by date, and design the pipeline to safely reprocess old partitions. Production lesson: late data is not an edge case, it is normal. Break number 5: schema change. Today, the source file has a column called price. Tomorrow, someone changes it to unit price, or they add a new column, or they remove a column. This is one of the most common ways pipelines break in real companies. So I will rename a column and run the pipeline. There are two possible outcomes. The pipeline fails loudly, or the pipeline continues and produces wrong data. Failing loudly is annoying, but silently producing wrong data is worse. The fix is: define an expected schema. Check column names and data types. If a required column is missing, stop the pipeline or quarantine the file. The production lesson is: your pipeline should know what data it expects. Do not let schema changes sneak into production quietly. Break number 6: bad date formats. In real files, dates are a nightmare. One file says 2026 613, another says 13 6 2026, another says 6 13 2026, another has text like June 13th. If your parser is too relaxed, it may create null dates. If it is too strict, it may fail too often. So I will add a mixed date formats. The fix is standardizing date parsing. Track parsing failures. Reject or quarantine rows with invalid dates. And always measure how many records fail at conversion. Production lesson: typecasting is not boring. Bad typecasting can destroy downstream analytics. Break number 7: wrong currency. Let's say some orders in US dollars, and some are in Indian rupees, and some are in euros. If we sum all prices directly, the revenue number is meaningless. This is a classic example of a pipeline that is technically correct but business wrong. The code can run perfectly, the SQL can be valid, the dashboard can refresh, but the metric is still wrong. The fix is: store currency code, use exchange rates, convert to a standard reporting currency, and never mix monetary values without knowing the currency. The production lesson here is: a good data engineer protects business meaning, not just data types. Break number 8: missing input file. Imagine the pipeline runs every morning, but today orders file never arrived. Should the pipeline still run? Or should it publish yesterday's data again? Or should it create an empty dashboard? This depends on the business requirement. But the pipeline should not silently pretend everything is okay. The fix is: add file arrival checks, add freshness checks, add expected row count checks. If today's data is missing, alert someone. Production lesson: no data is also data, and sometimes no data is a failure. Break number 9: duplicate partition load. This is related to idempotency. I will run the same date twice. If the pipeline appends records both times, the dashboard doubles revenue. That is bad. A production pipeline should be safe to rerun. The fix is: override the target partition, or merge using a stable key, or track processed files. But do not blindly append every time. Production lesson here is: every pipeline should answer this question: what happens if I run it twice? Break number 10: stale dashboard. This one is tricky because nothing looks broken. The last pipeline run succeeded. The dashboard loads, the charts appear, but the data is old. This happens often, and the business users hate it. The fix is: add freshness checks. Show the last updated timestamp. Alert if the data is older than expected. A dashboard should not only show numbers, it should show whether those numbers are fresh. The production lesson here is: correct data delivered late is still be useless. So here is our final scorecard. We tested duplicate rows, null IDs, negative revenue, late arriving data, schema changes, bad date formats, wrong currency, missing files, duplicate partition loads, and stale dashboards. If your pipeline handles all 10, it is already much closer to production ready than most beginner projects. And if it fails some of those tests, that is not bad. That is the point. We want to find failures before business users find them. The main lesson is this: a pipeline that works on clean data is not production ready. A production ready pipeline is one that knows how to fail safely. It catches duplicates. It validates business rules. It handles late data. It detects schema changes. It protects freshness. It supports reruns. And it alerts before bad data reaches the dashboard. So the next time you build a data engineering project, do not only ask, does the pipeline run? Ask, what happens when the data is wrong? This is where real data engineering begins. Comment break and tell me in the comment section which scenario you faced in production. Let's discuss about it. If this helped, drop a like and subscribe to Big Data Factory. This is all for today. I will meet you in the next video. Till then, keep learning and keep building. Bye bye.